Alright, so this talk is on Voxel subdivision for making 3D worlds. Got high detail to them. This kind of summarises what I'm talking about here. Take a very low resolution voxel-based world, think Minecraft, and apply a subdivision algorithm to add lots of texture and detail to it. So to start off with, a couple of talks we had before, we talked about how, well, I'll show you a graph, kind of the speed of GPUs is increasing a lot faster than the bandwidth to GPUs. Here's the slide from Ula's talk on the subject. And the kind of result of that is that more and more in the future we've got to start thinking about procedural graphics. So the idea is you're going to get most out of your GPU if you can type in low resolution data, but with a sort of high level meaning behind it, and the GPU processes and creates some high resolution geometry there. So procedural graphics is going to be something pretty important, I think, in the future. You could also say, well, this is also a reason why you just need really good compression algorithms, and that's pretty much the same thing, because a compression algorithm means you pass in high-level, low-resolution data and you get out high-resolution data. So they're kind of the same thing, procedural and various compression schemes. So here's an example of a type of subdivision that's very popular, mesh subdivision. So in this example, you pass in just a box to the GPU, and we have a little algorithm that runs that says, well, take a face of that box, let's say this face here, and split the face into 4 smaller faces, which are these 4 small faces here, but adjust the 4 smaller faces based on some knowledge of the neighbouring surrounding faces. And you apply that to all of the faces, and you get a higher resolution object, and you apply it again, and that's a very popular way of having smooth curved surfaces that runs on the GPU. So low resolution, you can kind of think of these as like spline handles, get passed in, and high resolution mesh comes out. So the idea of voxel subdivision is to do something very similar, but on voxels instead of on meshes. So let's consider just 2D for the moment. We take some voxels representing part of the world. Space can be white and the grey can be solid there. And a subdivision algorithm is an algorithm which takes that low resolution data and builds some high resolution data out of it. So if you think of a particular square here, how does it know whether to be on or off? Well, it uses an algorithm based on the low resolution data and based on the nearby, the nearest parents, you could say. So these are occupying the same space, right? And this is the low resolution data. We're going to replace it with high resolution data, and each of these squares is going to take the nearest, in this example, the nearest 4 kind of parent voxels and decide whether to be on or off based on what the parents are. Okay? So that's kind of, at its most general, the idea of voxel subdivision scheme. So, what subdivision rule do we use? I mean, there's a lot of different ones. If we're making a game, what we really want is a different rule for each terrain type, because if you think about it, various different rules are going to come up with different sort of shapes and different textures of results. So in a game, you probably want something like the sand areas to be using one subdivision rule and the smooth areas to be using a different one. Rocks, bushes, each have different subdivision rules. And then you can just pass in low resolution data, and depending on how close you are, you can see it in as much detail as you like. So how do we find these rules? And well, to start with, how many are there? So if these voxels are 1 bit, we only care about on or off, solid or air. Then if we're only looking at our 4 nearest parent voxels, then there's 2 to the 4, there are 16 patterns of the parents. And for each pattern, this can be on or off. So in fact, there are 2 to the 2 to the 4 rules. So even if this really simple case, there's already, I don't know, 16,000 different rules that are possible. And in more complicated cases, like in 3D, there's going to be hugely more again. There's a huge number of different ways that you can choose voxel subdivision rules. So the question then becomes, well, we've got a scheme which could be interesting to look at, but how do we find rules that look nice, that look like something that we'd actually want to make a game out of? There's probably not just one answer, but the way that I've done it is a kind of select and mutate scheme. So since we can actually count the rules, we can basically have a system where you can define the rule by just a little sequence, and if you modify that sequence a bit, then you're going to get a slightly different rule, and we can explore the set of rules by just selecting and mutating the options, and I'll show you what I mean by that. So this is the scheme I've been using. We've got, it's kind of hard to see at the moment, but we've got a rule here at the top, and these are 6 mutations of the rule. So I'll show you, if I click on this one down here, right, it brings that one to the top, and it mutates this, so there's 6 different mutations of that rule. And you can see if I clicked on that, so I brought it to the top, these now kind of look like variations of the top one. So this is a scheme for kind of searching for something interesting. I mean, we're still just in 2 dimensions here, but already we can see that this could be quite a fun scheme for finding patterns. Let's see if I can find something that looks a bit more natural. Keep on doing this for ages. If I keep on clicking the one at the top, then it will just continue to make different variations of it below.
Some great shapes for Space Invaders.
Yeah, all these ones are quite, quite kind of artificial looking, but you certainly can get some very natural looking ones.
Hundreds of platform worlds.
So, anyway, you kind of get the idea there a bit.
You're saying they can get a bit more organic, can't they?
Yeah, they certainly can. actually a better way to do it is to
Would there be any value in sort of almost drawing a shape by hand and trying to get it to match and say what
yeah, that's a
what's
different way to do it. I mean, here's one that is a bit more kind of rounded looking, and so you've got variations here that all kind of look a bit like
lily pads.
clouds or lily pads or something. And then you go, oh, that one's kind of strange. Something like that. So it's just a way to search it. There's certainly other ways to break it, but this was kind of the simplest way to really just be able to look through any kind of strange set of shapes. And all these are doing is they're different rules that say for various patterns of the nearest larger parent shapes, how do you for each pattern do you turn it on or off, you know, the smaller high resolution shape, and then you apply that once and then you apply it again and the next layer down and again, and each of these squares starts with just a 4x4 random set of 4x4 squares, and it'll apply the subdivision again and again and again and again. So that's how you get different shapes.
Is the random starting point, is it the same for each of the mutations? And it's just the rules that mutate, or do you pick the random starting point as well for independently for each one?
Well, all of those I'm just picking random 4x4s.
You pick a different random 4x4 for each one?
I think so, yeah. But the actual random 4x4 doesn't matter too much because it's the rule that gives the kind of shape. You know, you can pick anything for those 4x4 and you'll still get clouds, or you'll still get, you know, Space Invaders or whatever. So, here's some different ones that you can get using that set. I mean, I'm not sure what kind of game would involve those shapes, but as you can see, it's a big variety. This one's kind of interesting. It's got cracks in it, and I don't know.
The last one's really good.
Yeah, looks like a tile or something.
Bubbles on a soap bubble or something.
Some sort of amoeba.
Yeah.
Yeah.
Cell structure.
So that's 2 dimensions, and I don't really need to go into more detail to say you can extend that into 3D. You've got a lot bigger space to search through, but you can still do it. So here are some 3D shapes. It's exactly the same system for searching through them. So looking at these top ones here, it's quite common to get these kind of rock shapes. Again, this is now just a 4x4x4 of voxels, a random 4x4x4, and it's been subdivided. So I guess that one's kind of rocky. This has got lots of holes in it, sort of sponge, I guess. Don't know what that is. And you don't have to have your rules symmetric in each dimension. You know, you could have it so that it treats up and down as a different sideways, and that's how I get these ones at the bottom. To me, these kind of look a little bit like trees or something. And this is, well, I've added this one because this is the one I've actually put into a 3D system. So it's all very well being able to render kind of interesting shapes like that, but what I'm interested in is a world that you can be in where you can go up close to things and you can see things at the distance. So that's what I'm going to talk about next. So if you've got a 3D world that you want for your game, I don't know why that's saying that. So start off with a really low resolution voxel world, like a sort of Minecraft, but Boolean, so you've just got on or off for each voxel. So there's our voxel world that we're in. This is the camera. So the camera set point is there. subdivide these voxels near to the camera, right? And subdivide them again even closer to the camera, and subdivide them again even closer to the camera, right? So all your detail is up close where you need the detail, and further away you've got lower detail, and you don't get aliasing artifacts either because you're not trying to render high detail far away.
So if you've got a large model that goes from terrain, you do it on the same piece of terrain, like you have varying levels. So you wouldn't have to just do one, the whole thing in one go, just one level of detail.
I'm not sure what you mean.
Okay, so if you get something that's like is quite large, there's that part of it is like up close. You can have a different level of detail than the part which is further away.
Yeah.
Okay.
Yeah, so this is what I mean by these squares here, right?
Yeah.
This is where the camera is, all the detail is there, and this is... So the way you do it is that this outer level is stored in main memory,
Right.
and you can just use a paint tool to paint a kind of, beach with some trees, hills and trees, right? That's main memory, and then all these high details are just stored on the GPU, right? And so you also need an efficient scheme for creating, for subdividing voxels, because you don't want to be subdividing all of these every frame. So what you do is you only subdivide them when you move the camera. So if this is, a set of voxels and you move the camera that direction, then you only need to generate this dark grey set of voxels, and you generate them from the lower level detail down, right? So you only need to generate them, and as well, because we're using a square n by n grid, you can do a circular array, right? So I don't know if anyone's used circular arrays before, but basically, if you've got a bit of memory and you're going to be moving around in that memory, then you just change where the offset of the memory is, and it means that even though I'm moving, I don't have to allocate or deallocate any memory, because really when I'm creating this bar of voxels here, I'm just cutting off the ones on the other side.
Yeah.
So it's like a circular cube in each dimension. So it's pretty efficient. You only actually have to create the voxels when you move. Otherwise you can spin the camera around as fast as you like, and you've got this level of detail system.
And you see all that being done on the GPU?
Yeah, because GPUs can hold quite a lot of memory. I don't know if you've got the figures on how much they can hold these days, but they can. You've got GPUs with a gig of memory these days.
Not easily. 2.
Yeah, and this is the demo I'm about to show you is not on the GPU. It's a software renderer, single-threaded, not particularly optimized. So, but it still runs at decent speed.
If you move the camera, obviously you can use the same gun, but if you were to move the geometry, would that need to recalculate, or does it have to remain static?
Well, moving the geometry is a problem in these sort of worlds. I mean, I guess if you play Minecraft, I don't know how they deal with that, but moving geometry is a problem. You probably would want to, use a different rendering system for your
You
characters
just want to
moving
picture around
around.
and stuff that stays the same.
But you can get some interesting advantages out of this, like if you're walking down this direction and a bomb fell here and you just cut a hole, you'd only have to cut the hole in the lower level mesh, and when you came back to it, you would get you might have to swap it to the kind of crater subdivision rule, but then you... But basically, you can't really move the geometry in this system.
It's interesting that you can actually deform the geometry and do stuff with it though more easily in this kind of system, can't you?
Well, you can do kind of high level things to the geometry, like you can like add a volcano really easily, and if you get up close, you can see the details in it, even though you've only added voxels.
Could you do like procedural modifiers, like instead of having the crater cut out with the low detail geometry, just have some kind of modifier that the system knows about when it's doing its subdivision, and it can generate a crater without actually having to have that in the high level data?
Maybe. I mean, yeah, maybe. I'm not sure. Not sure. I'll just show you what it looks like. Okay, so what I've got here is I think it's 64 by 64 by 64 Boolean voxels, which the very front page you saw it was quite low resolution, and I can move around. Let's go down to here, this tree, or whatever you want to call it. So this landscape is it's basically just some hills and some kind of pole things that are like trees. So this pole here, you might be able to tell that that's the same subdivision rule that you saw the middle bottom one before. It looks quite similar. So we can change this whole landscape to a different subdivision rule, or we can make it look more like trees or whatever, but this is a kind of rocky one. So I'll just...
Are you trying to self-shadow them?
So the shadowing is a bit experimental, but you can see sort of here we've got quite a lot of detail, and then you can pull right out and it'll go down. You can actually see the various levels there, and that's mainly the shadowing. So if I turn off shadowing,
what's the visual effect if you roll the camera?
I haven't got a camera roll on this, so I can't show you. But the camera can roll.
Just because when we're looking at the voxels at different distances, they're sort of facing the screen facing rectangles. Wondering if they'll rotate to have a diagonal, or whether they'll still be screen facing rectangles, even with the roll.
If you roll the camera, they're still screens facing squares, but because they overlap a bit, so you probably wouldn't get any problem with a roll on the camera. It's a bit cleaner without the shadows, because the shadows are a bit of a hack. It only shadows things that you can actually see on the screen, so you can see it a bit better.
How have you chosen the distances at which to subdivide?
Well, once you've chosen one distance, it's powers of 2. So every time you double the distance from the camera, you're using half or double the size voxels, because that way on the screen, you want to make sure that all the voxels on screen look the same size.
Have you used a hard-coded value to start with, or do you actually calibrate it based on the pixel area versus the screen pixel size?
I've just chosen something. If the CPU ran faster, then I'd probably have a higher resolution one, because this is less than the actual native resolution. If it's on GPU, I'm sure you could run it pixel to pixel. But like I say, this is just single threaded. Anyway, so you've seen on the picture that these are actually much bigger voxels. I think every voxel is subdividing about 4 times or so you get about a 32 by 32 for each one. Beyond that, it doesn't bother.
How did you generate the input data to it?
Well, the input data is just because it's voxels, I just used a couple of algorithms. So it's some hills that are just sine waves, and then a few trees, which comes. I think the trees are just one voxel all the way up.
Mm-hmm.
So that's that.
Just use different rules to create the top head of the
No, that world is all one rule. I haven't experimented with putting different rules on different things, but of course it would look a lot better to be able to put different rules on different objects. But it would take more memory on the base resolution grid, because at the moment it's only 1 bit.
Right.
But if you made it like 4 bit, then you could have 16 different texture types. So fine.
But you're using like some rules to generate the high level data as well. Is that right? So it's basically procedural all the way down.
Well, no. Well, not really. I mean, I've just, because I didn't want to write a paint tool for this, I just put in a little algorithm for. But it just saves that to file. It's not procedural. The base level grid isn't procedural. That's just you can load up anything you like.
It's not different every time you load. You actually load the file in form says that.
Yeah. So finally, to summarise, some of the benefits of this idea, when you get continuous level of detail, the memory is always, in GPU, is always contiguous, and there's always a constant memory requirement. So that saves you so much hassle compared to other level of detail systems. It's nice. No allocation or deallocation of memory at all as you walk around the environment. And it's economic in its actual, when you call the subdivision rule, it's economical in how many times it calls it. So you can have a kind of more complicated rule and it won't slow it down too much. I guess one of the downsides is you can't move anything like you mentioned. Okay, any questions?
When you're submitting it to the GPU for render, is it all being converted to verts and polygons, or are you doing some other method to render it from the
Well, that was a software renderer, but you would. I'm not sure what sort of data structure you pass it up to the GPU as. Probably as a texture. I mean, it's literally just a Boolean 3D grid, so you can do 3D textures these days. So probably as that, and then you can make use of the texture compression that GPUs can use as well, I guess.
There's a choice because you can try and use the existing hardware pipeline to some extent, or you can try and do a CUDA or compute language thing and output a buffer from arbitrary data.
Yeah.
You should try using the geometry shaders.
I mean, you have to use CUDA. You couldn't use pretty sure you couldn't use just a normal pixel shader.
Yeah, so maybe it's silly just for flexibility. Yeah.
Couldn't you use the geometry shaders in DirectX 11? They can.
Well, they kind of don't issue that it's a mesh or something. I don't know.
I haven't done enough with them, but I'll leave it very primitive in what they can do. You're not going to generate complex or anything like this. It's more like it's adjusting certain tesselation parameters. It's very
How do you go about applying
basic.
like texture, like different colours? You get like the rule for geometry, and then
You can certainly have a rule for colours.
Yeah.
It makes the search space larger again to look through, but you can do something like find the right texture, lock that, and then search the colour space. Because I guess you would do a rule where you take the parent colours and then you decide what colour to do it based on parent colours. You can be careful not to make the search space so huge that you can't find anything in it.
When you're researching this, and you've obviously done some Voxel stuff before, have you looked at the other kinds of Voxel engines that have been around? There's some on the web. I see a few different.
Yeah, I've seen a few around. There aren't any that I've seen that actually do voxel subdivision. I haven't seen that before, but it could be that some
You're
people
saying
do.
it's sort of based upon a function infinitely deep, that kind of thing, as opposed to just compressing, like we saw in software with their creature. They're doing some compression and
Yeah, I mean, you could do things the other way, where you actually, an artist makes this really, really high resolution grid, you know, and then you find as good a subdivision scheme as you can, compression scheme as you can to compress it down, and then this stuff here, you're just ignoring the high resolution data. And so you still have a level of detail rendering system, but even with good compression, the size of the data sets will be a lot bigger.
Certainly.
Yeah.
There's sort of a few different, like for a Voxel render, we have content creation, and you're doing it sort of programmatically, or start with some source data, then define it, refine it down. Then there's sort of data structures for storing it and manipulating it, and then we've actually got the rendering and putting it onto the screen, different algorithms to draw blocks on the screen, really.
Yeah.
And I'm just wondering if how much research you've done in the different ways, because there seems to be a whole bunch of different ways to render voxels. And also whether you're doing arbitrary models or terrains, because remember terrains way back from the Nova Logic days of like Comanche and...
Well, I don't know if you went to my talk like 6 months ago. It's one of the first talks on Voxel, on a sort of Voxel renderer, and that was a different way of doing it. In that Voxel renderer, each sphere had children's spheres that could have their own transform. So, because of that, you could actually move, you know, a prop in the game, you can actually move it, even though it's Voxel. So it's sort of Voxel, sort of isn't. Whereas this one is like old-fashioned, stuck to the coordinates voxels, you know. But you gain a lot from having this because you don't have to worry about memory allocation and everything. It makes a lot of other things simpler, just doing circular buffers on cubic grids.
So you could always use a combination of this and your previous system to do the more direct stuff, couldn't you?
Well, you could use a combination of this and just normal mesh characters.
That's what I was thinking, like good for like large terrain areas or something like that.
You can spit out a Z for a Z or a W for a Z buffer, then you can
exactly, you can, yeah. So, and same for things like screen space ambient occlusion. You can do that post process. You don't have to do it in this. Okay, that's it.
Thank you.
Yeah, interesting. You certainly have a knack for these, or desire these.
Yeah.
What do you call them?
Procedural.
Procedural world.
Yeah.
Yeah.